Lesson 12-2, Geometric Sequences and Series. We just completed Lesson 12.1 on arithmetic sequence. Arithmetic sequence is generated when we repeatedly add a number D, known as the common difference, to an initial term A1. We are now going to take a look at what geometric sequences do. We will also start by a first term that we call A1, but instead of adding a number D, we are instead going to repeatedly multiply by a constant called the common ratio. So you will still have a list of terms, and the latter term, A sub k plus 1, will always equal the prior term times some common ratio. So if you ever want to figure out what the value of R is, what you're going to do is take the latter term and divide it by the previous term. So this here just means the latter term, the one that comes later. And they need to be consecutive, by the way. Okay. And this one is the previous term. So if you also recall when we did arithmetic sequences, to find the common difference, you took the latter term and subtracted the previous term. For geometric, you're going to take the latter term and you are going to divide by the previous term. So, just like arithmetic sequences, you have an explicit formula for geometric. You will always, when asked to when asked to find the explicit formula, you will substitute in two locations, just like you did with arithmetic. I need you to find the first term that we represented by A sub 1, and I want you to find the common ratio, R, which I just showed you what the formula is. So always substitute A1 and your R, and that's your explicit formula once you have written it out completely. That nth term formula helps you find any term given its position of a sequence. Okay, so let's show you what that looks like. So in example number 1, they're asking us to find the 8th term of the geometric sequence. The 8th term, shorthand, is A sub 8. That's what they're looking for, the 8th term. And anytime I ask you to find a term, I need you to automatically find the explicit formula. Because once you have the explicit formula, you can actually find any term that you want. Okay? So again, the explicit formula, A sub n equals A sub 1 times R to the n minus 1, requires that you substitute A sub 1 and R. A sub 1 and R. Do I have an A sub 1? A sub 1 is known as the first term. I sure do have an A sub 1. Do I have an R? Well, the R is easily found by taking the latter term and divide it by the previous term. The latter term divided by the previous term. And you can do that as many times as you want to make sure that every single time it indeed ends up being the same number. And in this case, our R value is equal to 3. Every single time it turned out to be 3. So I do have an A1 and an R. So my explicit formula is my first term times, and I always put my R in parentheses, and I raise it to the n minus 1 power. That's your explicit formula. That explicit formula helps you find, let me actually box that in a little bit better. That explicit formula helps you find whichever term you are looking for. I specifically had asked to find A sub 8. So if I'm going to replace A sub n with A sub 8, that will help me find it. So since a sub 8, the 8 is replacing the n value, that means when I rewrite the formula, I'm going to put the 8 for the n, and I just have to type that whole thing into the calculator. And let's see, I already worked that one out, and you would get 10,935. So on the 8th spot in our sequence, that's what we're going to find for that spot, the number 10,935, that term. Okay? So the explicit formula is a very powerful tool. Let's try example number 2. A geometric sequence has a first term of 3. So let's go ahead and write the shorthand to that. So first term of 3, so A1, meaning first term is 3. A common ratio of -1/2. So R is -1/2. That's a spelling error there. And they want us to find the first 5 terms and the 10th term. So again, anytime I ask you to find terms, I want you to write an explicit formula. So do I have an A1 and an R? So let's look. A1, I don't have it. I got it. Oh, no, sorry, I do have it. I'm thinking 3 is A sub 3. A1, I do have it, and R, I do have it. So let's write the formula right off the bat. A sub n equals A1 times my R to the n minus 1. That's just my formula. Okay, that's my formula. I'm going to box it in because even though they're not telling me here in this problem, give me the formula, I'm going to go ahead and do it, but box it in because that's how important it is. Okay, they asked us to find the first 5 terms. Well, the first 5 terms are easy to find because if I know the first term, 3, right? Let me write that better here. If I know the first term is 3, and my R is -1/2, that means I just keep multiplying. Well, 3 times -1/2 is just -3/2. And -3/2 times a -1/2 is just going to give me 3/4. Okay, follow me? -3 times -1 is 3. 2 times 2 is 4. Then I have to multiply it again by -1/2. Well, 3 times -1 is -3. 4 times 2 is 8. I'm going to do it one more time because they wanted 5 terms. Multiply by half again. -3 times -1 is 3. 8 times 2 is 16. So there are the first 5 terms. Now I can keep doing that over and over and over again until I get to the 10th term. But why am I going to do that when I can just use a formula, right? So the 10th term, that's 10th term. That's what A means. The letter A represents the word term. Yeah, I mean, you could even use the letter T if you wanted to, but A sub 10 is the 10th term, and that's going to equal 3 times -1/2. How many terms do we have? 10. We're looking for 10 minus 1. If you type that all out into your calculator, you should get -3/512. That is your 10th term that was being asked for, right over here. Okay, that's your A sub 10. And you could have done that for every single one. You could have found A sub 1, A sub 2, A sub 3, A sub 4, A sub 5 by just plugging in 1, 2, 3, 4, 5 into your formula. So feel free to do it that way as well. All right, example 3. They are wanting to give us some terms. And again, they're asking us to find the formula in a specific term. Now let's look at what they gave us first, okay? So they gave us the geometric sequence is a 5, the third term. So third term, they said, is a 5. So I'm going to write A sub 3 is a 5. And then they said the sixth term is a negative 40. Okay. So let me write down 6 terms. So a sub 6 is negative 40. Okay. So they want us to find the 8th term and provide the explicit formula. So again, if you are looking for the explicit formula, you must find A1 and R. If it was arithmetic, you'd say A1 and D, okay? A1 is not given to us, R is not given to us, so let's go find it. So I'm going to use my AN formula. Okay, so I'm going to write this AN formula out here so that you could see what I'm doing. So I'm writing it in black, I'm boxing it in here because this is just a reference of what we're going to use. I'm going to use that reference formula right there to write my 2 equations because I have 2 unknowns. Okay, these are 2 unknowns here. A1 and R are 2 unknown values. And if you have 2 unknown values, I need 2 equations written in 2 variable form to solve for it. Okay. Now A sub n means give me a term. A sub n is what is a number in your sequence. Give me a number. So with that first term, I have a 5, and the second term I have a negative 40. I'm going to start with the bigger absolute value number. So the absolute value of 5 is just 5. The absolute value of negative 40 is just 40. So I'm going to start with A6, the one that's further down. So I'm going to rewrite this in nth term format. So negative 40 is equal to A sub 1 times R. And I'm writing A sub 1 and R because I don't know what it is. And how many terms are there? Well, negative 40 is in the 6th position. So there's 6 numbers minus 1. I'm going to do it for the other one. 5 equals A sub 1 times R. And this one had 3 terms. 3 minus 1. Okay? So what you're going to notice is when you write this down, what I want you to do is write them one above the other, because when you do it, if you write it as a ratio, right, I'm going to put a division line here. Whatever I do to one side, I'm going to do it to the other side, okay? And I'm going to actually, hold on. Let me lower this down here. Let's put this division here. All right, and let me put 3, 1 as 1. So I'm putting these division signs because if I divide on one side and I just merge this equal into an equal sign, the negative 40 over the 5 is going to become a negative 8. The A sub 1 is going to end up canceling, right? And now you have R to the 5th over R to the 2nd, because 6 minus 1 is 5, right? And 3 minus 1 is 2. And R to the 5 over R to the 2nd is R to the 3rd power. Okay, so I'm going to divide these numbers. Then I need to solve for R. So I need to multiply this by the reciprocal. And whatever I do to one side, I have to do it to the other side. And that way the R becomes R to the 1 power, or just R. And if I type in negative 8 to the 1/3, the cube root of negative 8 is negative 2. So there is the R. That's one of the 2 things I needed to find. R and A1. Once you find R, I need you to pick one of the equations, okay? So pick an equation, whichever one you want. I'm going to pick the one with the 5 because that one's a little bit smaller numbers. The 5 equals the A sub 1, that's what we're looking for, times the R I already know that the r is -2 because I just found it, to the 3 minus 1. And 3 minus 1 we know is 2. -2 squared is a 4. And to solve for a sub 1, I have to divide both sides by 4. So that a sub 1 will be isolated. A sub 1 is 5/4. So here's my other unknown variable. So now that I have a1 and r, I can write out my explicit formula. A sub n equals my a1 5/4 times my r -2 to the n minus 1. There's that very important piece. Okay, so they asked us to find the 8th term, so let's find the 8th term. So a sub 8, we could find any term, right? But they asked us to find the 8th. So for n being 8, we put 8 minus 1 in the exponent, and when you type that out, the 8th term is going to end up being -160. And that is part of the answer as well, because they asked us for two things: the explicit formula, which is this one in the oval, and the 8th term. Anytime they ask you for a term, use the explicit formula. Okay, moving on to the next page. We have what's called series, which are sums of the terms in our sequence of numbers. Series is just a sum of terms in our sequence. Okay, now you, unlike the arithmetic sequences, you will see that for geometric sequences we have two types of sum formulas. This is the first one that I'm highlighting right now in yellow. Okay, this first one is used to find finite sums. Finite sums are sums of terms in a sequence that are stipulated to a certain number. So you will have a list of numbers that terminate. That's a finite sum. Let me show you an example what that looks like in this application problem. A man wishes to save money by setting aside 1 cent the first day, 2 cents the second day, 4 cents the third day, and so forth. If he continues to double the amount of money set aside each day, how much must he set aside on the 15th day? Well, we started with a visual. 1 cent, put in a jar. 2 cents were put in a jar. 4 cents were put in a jar. And they just kept going like that, right? On and on. That's the list, all right? So what's going to happen if he doubles the amount every single time, like we're showing in that sequence of numbers? How much will he have to set aside for the 15th day? So what is a sub 15? He's asking, or the question is asking, what number is in that 15th position? Okay? Again, when I'm asking you to find a term, go do the explicit formula. A sub n equals your first term, a1, which is a 1, times your r. Well, we can tell that the r is going to be consistently a 2 because 2 divided by 1 is 2, 4 divided by 2 is 2, 8 divided by 4 is 2. So it continues, right? So we know it's a 2. R is a 2. So put my r in parentheses to the n minus 1. That's my explicit formula. So if I need to find a15, it's pretty easy because a put the 15 for the n. So I'm looking for the 15th term equals 1 times 2 to the 15 minus 1. And example 4, when you type all of that out, you're going to get 16,384 cents. But if you want it in dollar amount, divide it by 200, and we get $163.84. So on the 15th day, this man has to deposit that much money into his savings. So let's assume he does not run out of money. Okay, let's assume he does not run out of money. So it just keeps going. What is the total amount that he saved at the end of 30 days? So notice that they're asking us to add 30 terms. Whatever he made on the first day, whatever he put in the second day, whatever he put in the third day, and all those amounts we're being tasked to add them up. Because they only want the up to the 30th day, okay, the end of 30 days and no further, that's a finite adding, finite sum. So our formula upstairs for finite term says to calculate S sub n. So for us, our n is 30. So S sub 30, which means add the first 30 terms. Sum up the first 30 terms. Capital S is sum. Okay? Take the sum of the first 30 terms by getting A1. Well, A1 we said was just a 1, first term, times, so we have 1 minus the R. The R was a 2 to the nth power, not n minus 1, to the nth power over 1 minus 2. Type out that all in the calculator. Oh, my n is 30. My bad. There we go. Type that out into the calculator. Okay. So 1,073,741,823 cents. Or divide by 100 and you get 10,737,418.23. It's a lot of money saved up by doubling your money every single day for just a month. The total amount of money accrued would have been 10 million plus. So that's a finite sum because they only asked us to add the first 30 days. Now, here's the second formula for sum. S equals A sub 1 over 1 minus R. This has to do when it's infinite geometric series. But I need to make sure that you are always making sure that the absolute value of R is less than 1. Okay? You must make sure that the absolute value of R is less than 1. Okay. If your absolute value of R is less than 1, you are going to tell me that it diverges. The sum cannot be calculated. Okay? The sum will not be able to be calculated. So for this formula, you would just ignore it. You wouldn't use it. You can't do it. Let's work out a problem that involves a finite sum. An infinite sum. So notice it's infinite because of those ellipses, right? And what they're asking us is they're giving us a sequence of numbers and they're asking us to find the sum. And anytime you see find the sum has a, what do you call, hold on, what is it called? That's even bothering me. It's not making me concentrate. Synonym, okay? Sum is a synonym to series. All right, a sum of terms. Find the sum of the infinite geometric series if it exists. Well, according to my formula, S is equal to A sub 1 over 1 minus R. So I need A sub 1 and R. Well, A sub 1, I already have it, so that's good. No extra work there. R, I need to figure it out. So let's do R. The latter term divided by the prior term, which we know is the same thing as saying 2/5 times 1 over 2. The 2's are going to cancel. And so 1 over 5 is your R. So I have an A1 and an R. So now I'm able to calculate the sum, the infinite sum. Substitute A1 to be 2. 1 minus the R is 1/5. That calculation ends up to be 5/2. So all those terms added together would give you 5/2. All right, last but not least, I need you to be able to write an infinite repeating decimal. I want you to be able to convert it into a rational number. Rational number is just another word for fraction. Okay, so notice I'm giving you here a repeating decimal of 5.427 repeating. So 427 repeating means that I have to write 427, 427, 427 continuously forevermore. Okay? So I want to be able to rewrite 5.427 as a fraction. So in order to convert a 5, let me write this down here. I want to convert this to a fraction, okay? You are going to, I don't know what that was doing. You are going to follow some steps by rewriting the decimal as a series. And I'm going to walk you through what that looks like, okay? So, our number is 5.427. How can we rewrite it as a series? You guys know, I've said this over and over again, that series just means a sum. So if I want to write the number 5.427 as a sum of two numbers, couldn't I just write it as 5 plus 0.427 repeating? Do you not agree? Okay, so what I want to do is I want to rewrite this repeating decimal as a fraction, okay? I need to rewrite it as a fraction. And then once I know how to rewrite 0.427 as a fraction, I'll go back and add it to 5, okay? So let's rewrite. So rewrite. So 0.427 repeating is the same thing as saying 0.427 plus 0.000427 plus 0.000000427, and so forth. Is it not? Think about it. If we wrote it one above the other, watch this, 0.427, and the next term, 0.00427, 0.000000427. If I stack them one above the other, wouldn't that, and I added them, the 4 and 0 is a 4, 2 0 is a 0, 7 0 is a 7, 4 and 0 is a 4, 2 and 0 is a 2, 7 0. Isn't that dot dot dot? Isn't that 427, 427, 427? Okay, so when I rewrite it that way, I just finished rewriting it as a series. Okay, this right here is a series because it's a sum of terms. That's a series. So I can use the series formula to figure out what that is equal to. Okay, but remember, my series formula for infinite is gonna need an A1 and an R, right? An A1 and an R. So, do I have an A1? I sure do. This is my first term, A1. Do I have an R? Well, not yet, but I can find it. R is the same thing as the latter term. So I'm going to pick one of my terms and divide it by the previous term. Well, the number in front of 0.00427 is 0.427. And when I divide those two, the R ends up being 0.001. And here's the good news. Is my R less than 1? Because up here, they told us the R has to be always less than 1. Okay? If it's not less than 1, then I cannot use the formula. Okay? But 0.001 is definitely less than 1, so I can use the formula. So let's go use that formula. The formula says to find the sum, I needed to find A1, 0.427, and I have to divide it by 1 minus R. 1 minus 0.001. And when I put that into the calculator and convert it into a fraction or whatnot, I'm going to end up with 427 over 999. Now, don't forget that that was just the series piece, right? The S equals 427 over 999. That was just this piece, okay? I'm looking to rewrite this. So I have to not forget, I have to add 5 to the answer that I just got to 4.27 repeating. So let's go do that. Okay, so my 5.427 repeating says that I have to take the 5 and I have to add it to 427 over 999. And when I do that, I get 5,422 over 999. And I want to challenge you, okay, that when you get your final answer, go ahead and type it into the calculator and convert it to a decimal and make sure it looks like 5.427 repeating like your given problem, which in this case it would. Okay. For part B, I'm just going to probably just start you out on this problem and let you work it out. But look at the difference with this one. your problem was 2.351 is being repeated. Just the 51, okay? So first you rewrite it as a sum of two terms, okay? Notice in part A, we first wrote the non-repeating part. See that here? That was non-repeating. And then the second part was the repeating part, okay? Second part was the repeating part. So you do the same thing here, okay? So the non-repeating part is this part, 2.3. Okay? 2.3 is the non-repeating part. So I have to write 2.3 plus what's going to be the repeating part. Well, 2.3 plus 0.0, I have to put a placeholder, 5, 1, repeating, okay? And give you the visual, 2.3 plus 0.051 repeating is 2.351 repeating, so which is the original problem, okay? So make sure you are rewriting this correctly. All right. So the 2.3 is placed on hold, and I need us to go find the summation of 0.051. I need to write a whole bunch of terms that are equivalent to that. So rewrite the decimal repeating portion, 0.051. What does that look like when we rewrite it? Well, it would be 0.051 plus, what would be next? Well, I need a 0.000 to cover the first three, and then another 51 comes right after it. Then I'll do it again. Well, then I'd have to cover the first 5 digits, 1, 2, 3, 4, 5, and then attach another 51. And I can do that forever, right? So go ahead and go from here. You know that this is your A1. Go find out your R by doing latter term divided by the prior term. Go find the R. And I'm going to go ahead and tell you that as you work this out on your own, the final answer to this problem would be 388 over 165. But do take the time to try and work this out on your own, okay? Thanks for watching.